Alumina threaded rod, a ceramic screw-like fastener that combines mechanical strength with electrical insulation and thermal stability. Unlike solid ceramic bars, this product has precision machined threads, turning it into a true fastener that can be tightened, torqued, and locked with matching ceramic nuts. Available in metric thread sizes from M2 to M18, with alumina purity from 95% up to 99.7%, supporting continuous service temperatures from 1,450 up to 1,730 degrees Celsius. For benefits, make this product essential where metal fasteners would fail. First, secure mechanical fastening at high temperatures. The threaded design holds load stably above 1,200 degrees Celsius, where metal screws loosen, oxidize, or seize. Second, precise alignment and assembly compatibility. Machined threads from M2 to M18 hold tolerance to plus or minus 0.2 millimeters, mating accurately with alumina nuts and washers for repeatable installation. Third, reduce particle contamination. Unlike metal fasteners that oxidize and shed metal particles at high heat, alumina threaded rods maintain complete surface integrity. And fourth, longer service life in aggressive environments. The combination of inert ceramic material and positive thread locking minimizes replacement cycles in corrosive chemical setups. In laboratory analytical instruments, the threaded geometry enables micrometer level height control that a smooth rod cannot achieve. A fine pitch thread such as M6 by 0.5 millimeters advances exactly 0.5 millimeters per full turn, which means a quarter turn is 0.125 millimeters, and an eighth turn is 0.0625 millimeters. A European analytical instrument. OM replaced clamp-held metal hardware with M6 by 0.5 alumina threaded rods in their TGA and DSC fixtures. Pan height repeatability improved from plus or minus 0.45 millimeters to plus or minus 0.10 millimeters using quarter-turn adjustments. Setup time per instrument dropped from 18 minutes to 6 minutes because technicians no longer needed clamp and shim procedures, just thread-based micro-positioning across 200 thermal cycles up to 1,000 degrees Celsius. No loosening events were recorded, and metallurgen contamination alerts fell from 3 per 100 runs down to 0. In industrial furnaces, the same threaded geometry solves a different problem: heater element support under continuous high temperature load. An automotive heat treatment line converted a 1,200 degree Celsius box furnace from metal clamps to threaded alumina rods with ceramic nuts, supporting MoSi₂'s heating elements. The mechanisms drive the improvement. First, the alumina threaded joint has a matched coefficient of thermal expansion, roughly 8 times 10 to the minus 6 per Kelvin, while metal fixtures expand at nearly twice that rate, creating stress that fractures supports over time. Second, positive thread engagement holds clamp load through thermal cycling, retaining more than 95% torque after 300 cycles at 1,100 degrees Celsius. The measured results element sag failures dropped from 4.1 to 0.6 per thousand operating hours. Zone temperature uniformity improved from plus or minus 18 to plus or minus 7 degrees Celsius, and retorque intervals extended from weekly to quarterly. Unplanned downtime was reduced by 22 hours per month. In chemical processing, the third application combines thread precision with aluminous chemical inertness. A specialty chemicals pilot plant replaced 316 stainless steel M8 studs on a PTFE-lined reactor manway cycling between 20% hydrochloric acid at 50 degrees and 30% sodium hydroxide. SIP at 80 degrees with M8 alumina threaded rods and alumina nuts. The ceramic thread pairs avoid galling and seizure entirely. Leak rate fell from 4.2 times 10 to the minus 6th down to 8 times 10 to the minus 7th millibar liters per second, thanks to 0.125 millimeter step preload control. After 180 alternating acid caustic cycles per quarter, torque retention held at 96%, with 0 frozen fasteners. Maintenance time per reactor opening dropped from 45 minutes to 12 minutes, and stud replacement intervals extended from 2 months to at least 6 months.